Okay, well, welcome back. Today we're going to start with an opener. Now that you know how to find the sine and cosine and tangents of angles in a right triangle, let's see if you can find the cosine of angle M for this right triangle. Now, as I go through these examples, I think it's a good idea for you to hit pause and then try and do it yourself. The PDF of the notes are in Schoology as well, so you can download that if you want, or just on a piece of scratch paper. Try and come up with the answer first instead of just watching me work through it, and then compare your answer, and that way you're thinking more about it and you're being more of an active learner. Okay, so hopefully you've tried this and come up with a solution. Now, what we've learned is, first of all, let's mark the angle that we're dealing with. So we're dealing with angle M, and the cosine, from what we remember, SOH CAH TOA. Okay, the cosine is the adjacent over the hypotenuse. So if I label my sides, this is the opposite side, this is the hypotenuse, and this is the adjacent. So the cosine of angle M is going to be adjacent over hypotenuse. Except there's a problem here. We don't know what the adjacent side is. Nothing was given. So what does that mean? We can't do the problem? No. It means we have to figure out how to come up with the length of that side. So now we have to think of, what else do we remember? And we've done this several times in a right triangle. If you know two of the three sides, we can use Pythagorean theorem. Which, let's say I call this side A and this side B and this side C, we know that A squared plus B squared equals C squared. So with the Pythagorean theorem, we can set this up and say A squared, which is our adjacent side, plus 15 squared, which is the opposite leg, equals the hypotenuse squared. And then we can grab our calculator and subtract 15 squared from 25 squared. And it turns out that you're going to get A is equal to 20. So, the cosine of angle M is 20 over 25. And remember, we always said you should reduce if you can. So that's 4 over 5. Alright, but that wasn't the real opener. Here's your real opener. I'd like you to find the length of side BC. So that's one of the legs in this triangle. Now this is different because I didn't give you all three sides. I didn't even give you two sides, and now we know how to find the third side. But this time I actually gave you an angle. So let's see how we can deal with this approach. So this is the angle we're dealing with. Let's label all the sides. Hypotenuse, opposite leg, adjacent leg. So we do have a number for the adjacent leg, which is 12. We're trying to find side BC, which is the opposite side. So that's what we're looking for. So we really don't need to use the hypotenuse. So now, we want to use something that deals with the opposite side and the adjacent side. From SOH CAH TOA, that's the tangent, wasn't it? So, we're going to say the tangent, get rid of this, the tangent of angle A, which happens to be 35 degrees, we usually just wrote the letter A, but the tangent of 35 degrees equals the opposite leg, which we don't know. That's what we're trying to find out. Maybe I should write OPP so you don't think that's a 0. Over the adjacent leg, which is 12. So it might make it a little easier for you if we just call this side X. Actually, let's get color coordinated here. Let's do it in blue. We'll call that X. So then we still know this is the opposite leg. Okay, so what we have here now is tangent of 35 is equal to x over 12. Now, what I want you to remember is that sine, cosine, tangent, those are just ratios. Those are actually just numbers. So think of this as just a number. So if I had told you, for example, that 5 equals x over 12, you wouldn't have any problem solving that equation. So don't let the more complicated version, tangent of 35, now it's not 5, but the tangent of 35, don't let that distract you. That's just a number. Alright, so how would we solve this? Well, whatever the number is for tangent of 35, if we multiply both sides by 12, and then when I multiply by 12 on this side, the 12's cancel, so I'll just have x. So we get x is equal to 12 times whatever the tangent of 35 is. Now this is where our calculator is going to come in handy, and we're going to have to use a calculator for this. So the first thing you want to do is make sure that you are in degree mode. So on this calculator I have to go to mode, and you can see degree is highlighted, so I'm good. On scientific calculators there's usually a D or an R, and you want to make sure the D is set up, which stands for degree. And most calculators default to degree. And now if I press the tangent button, TAN, and then I type in 35, the calculator will give me the number that the tangent of 35 equals, and it's going to be a decimal. So 0.700207, so we get this decimal, it's going to go on forever. So now what should we do with that? Well, we want to do 12 times that. So what I could have done is I could have just punched in 12 times tangent of 35. And there's my answer, and let's say if we go, how about we go 2 decimals? So 8.40. Approximately. So find the length of side BC. There's your answer. There's no units in this picture, so we don't have to put any units down for that. So almost 8.5 units long is the length of that side. So now you can see that once you understood from the last lesson how to figure out the tangent or the sine or the cosine and those ratios, we can make an equation using one of those three, and that's going to help us find missing parts of a triangle. Okay, so as I just showed you, to get the decimal approximation for one of your trig functions, make sure you're in degree mode, and then just press the button and type in your desired angle. So I have some examples set up here. Give me some more room. So for example, if I just said, what's the sine of 38 degrees? Punch it in, it's about 0.615 or 616. What's the cosine of 75? What's the tangent of 26? So you can get, and those are decimals, which we could write as a ratio, but the calculator isn't going to give us fractions for all these because they would be really complicated fractions. So they're just giving us the decimals for these. All right, so let's try and use this idea to solve some parts of a triangle. So in this example, find the length of side BC. So it's kind of like the last problem we did. So first of all, here's the angle we're dealing with. Label your sides, hypotenuse, opposite, adjacent. They want side BC, so I'm going to call that X. And so now let's look at what we have. We have a number for the hypotenuse, and we're trying to find the opposite. So those are the two functions that we're going to, or the two sides that we're going to use, the hypotenuse and the opposite. If it helps at the top of your paper, write SOH CAH TOA. So which one of those, is it the sine, the cosine, or the tangent that uses opposite over hypotenuse? Hopefully you looked and recognized that was the sine. So that tells you you need to use the sine function. That's how we figure out which one of the three we need to use. Label your sides, look at the two sides that you're going to have to use, and then decide from SOH CAH TOA which one we're going to do, sine, cosine, or tangent. Alright, so let's set it up. The sine of our angle, which we know, so I'm going to plug in 52 for that, is equal to the opposite, which is x, over the hypotenuse, which is 8. So remember, sine of 52 is just going to be a decimal if we punch it in on our calculator. So to solve this equation for x, we're dividing by 8, so we need to do the opposite, multiply both sides by 8. And so the 8's will cancel on the right side, and we'll just have x. And now we're going to grab our calculator and punch in 8 times the sine of 52. And as you can see, we get approximately 6.30 if we go round to 2 decimals. And there's no units in this problem, so we don't have to write units. And that's it. Pretty simple. But we need a calculator to solve this. Alright, let's try another example. And just saw the answer. No peeking. Alright. Find the length of side XW. This is a good place where maybe you want to hit pause and try this yourself. And then come back and play and see if you got it right. So here we go. Here's the angle we're looking at. Let's label. This is the hypotenuse. This is the opposite leg. This is the adjacent leg. They want us to find the length of XW. XW, so that's right here. I'll use a little x for that. And now we have to decide which ones are we going to use. Well, we have 15 for the adjacent, so that's one we're going to use. We're trying to find the hypotenuse, and so that's the one we're going to use. So we don't need to use the opposite. We want hypotenuse and adjacent. So if you look at SOH CAH TOA, which one uses adjacent and hypotenuse? That would be the cosine. So the cosine of 39 degrees is equal to the adjacent, 15, over the hypotenuse, which is x. Now this one is different than the other equations we've solved. This time x is in the denominator. So let me refresh your memory. What if I said 4 equals 15 over x? I'm not saying the cosine of 39 is 4. I'm just throwing in a number. How would you solve that? Well, I think maybe one of the easier ways for you to deal with this is make the 4 a fraction, make it 4 over 1. And then that should remind you of all the proportions that we worked on. You would cross multiply. So 4 times x equals 1 times 15. So 4x is equal to 15. Another way to think about that, if you don't like that way, instead of cross multiplying and making a fraction, you can do it just like we did the other problem and say, well, let's multiply both sides by x. These x's cancel, and there you go. 4 times x equals 15. And then divide by 4, and we'll get x equals 15 divided by 4. Alright. So, let's solve this problem. Basically what I'm going to do is multiply both sides by x, so I'll have x on the left side, and then I'll divide the cosine 39 to the right side, and so after following those steps, this is what I'm going to wind up with. 15 divided by cosine of 39. And if you punch that in your calculator, you get about 19.30. And that's it. And that makes sense because we know the hypotenuse is the biggest side, so your answer should definitely be more than 15. Alright, let's try one last problem. I want you to find the measure of angle A. This time you have all three sides, but we don't know the measure of angle A, or B for that matter. So how do we do this? Well, this is a problem where you're going to have many choices on how you want to set it up, so you decide. So let's do what we've always been doing. Let's label the triangle first. So for angle A, we have the hypotenuse. This would be the opposite side, and this would be the adjacent side. Now since we have all three of those sides, we have the lengths 6, 8, and 10, you can pick any two that you like. Let's say I decide I'm going to use the 8 and the 10. So that's the opposite and the hypotenuse. So which one in SOH CAH TOA uses opposite and hypotenuse? Well, that would be the sine. So the sine of the angle, this time I don't know the angle, so I'm just writing sine of angle A equals the opposite over the hypotenuse. This is kind of what we did in the first day lesson, and we just reduced the fraction and we were done. But now I'm going to show you how we can actually figure out what that angle A is. Now, I need to figure out what the angle A is here, which means I need to undo the sine. So what I want you to think about is this problem. What if I said the square root of x equals, I don't know, 5? Everybody knows how to solve that. You square both sides, because squaring undoes the square root, and so then we just have x, and then 5 times 5 is 25. Okay. So it's the same idea. The sine is a function, just like the square root is a function. So what we want to do is undo the sine. Well, how do you undo the sine? That's something that you don't know yet. And so it turns out that our calculator is going to be helpful, as we have this function called the inverse sine. And it doesn't mean sine to the negative first power. If you remember back in algebra, you had functions like f of x. Well, now we have something called an inverse of f, and that's the notation we use. Don't confuse that with a negative exponent. That just means the inverse. Alright, so it undoes the sine. So when you have a problem, sine of a equals 8 over 10, to find angle A, you're going to do the inverse of sine of the fraction 8 over 10. So let me show you on the calculator how that works. So grab the calculator. If you notice on any calculator, above the sine, cosine, and tangent, you see the sine to that negative 1 power and the cosine to the negative 1 and tangent. Those are the inverse functions. So to access that, I'm going to have to press the second button and then press the sine button. And then I type in 8 divided by 10. And this is going to give me the angle A that we're looking for. And so if I round to 1 decimal, I'd say 53.1. Let me type that in. Oops. So A is approximately 53.1. And this is an angle, so it's in degrees. And so that's how we can find angles now, since we're familiar with how to set up a sine, cosine, or tangent. Now, what if somebody else said, hey, I don't like the sine, I really like cosine? That's fine. Cosine is the adjacent over the hypotenuse. And you could have set it up and said, oh, the cosine of angle A is equal to adjacent, which is 6, over the hypotenuse, which is 10. And then to get angle A, to undo cosine, we're going to do the inverse cosine of 6 over 10. And then we grab our calculator, and we type in second cosine, 6 divided by 10. Oh my gosh, same answer. It doesn't matter. Well, it should be. We should have the same angle for whatever we set it up with. So we'll get the same answer for that. And then lastly, what if somebody else said, oh, I wanted to use the tangent? Well, that's fine. For tangent, they would use opposite and adjacent, and they would have said tangent of angle A is the opposite, which is 8, over the adjacent, which is 6. And so then to undo tangent, we do the inverse tangent function, of 8 over 6. Grab the calculator, and we type in second tangent, 8 divided by 6. Lo and behold, same answer again. So you get your choice on these problems on how you want to set it up. But you're going to get the same answer whichever way you do it. So pick the way that you like to use, the one that makes the most sense to you. So 53.1 degrees there, and 53.1 degrees here. So whichever way you like to do it, go ahead and do it. Okay, so now the assignment today is going to be worksheet 3, which will be in Schoology. And this is what it looks like, so I just want 2 quick minutes to make sure you understand all the different parts. Part 1 says calculate the answer round to 4 decimal places. So read the directions. All you're going to do for this one is you're going to grab your calculator, use the one on your iPad, or if you have a regular calculator laying around, type in sine of 32 and write down what it shows you. So that's what you do for the first 6. For part 2, it says solve for the missing angle, round to the nearest tenth. So the sine of A equals that decimal. So to find angle A, you're going to do the inverse sine like we just worked on. And this time, instead of punching in a fraction, you're punching in a decimal. And then just grab the calculator and do second sine 0.1234 and write down what it gives you. So that's pretty straightforward. Now for part 3, you have to find the missing angle that they're showing you. So for this problem, you mark the angle, label your sides. This is hypotenuse. This is opposite. This is adjacent. They're giving us numbers for opposite and adjacent, so that's tangent. So you're going to set up your equation tangent of x equals opposite over adjacent. And then to figure out what the angle is, we have to undo tangent. So you're going to grab the calculator and do second tangent 25 over 15 and write your answer. They didn't specify here, so let's say nearest tenth. So let's go 1 decimal on these. Okay, so that side's pretty straightforward. On the back side of the worksheet, we have some problems that say part 4 says solve the triangle. I'm going to come back to that in a second. Part 5 says solve for x. This is like the first few examples I did in the notes. So you decide, label your triangle, mark your angle, label your triangle, decide what sides you're using. In this case, it's the hypotenuse and opposite. You write down your trig function, is that sine or cosine or tangent, and then you solve for x. Now for this other part, this is the toughest part of the worksheet. You have to solve the triangle. What that means is find all the missing sides, all the missing angles. So in number 1, you have 2 of the sides. I would probably first start by finding W. And that's like the example we did using the Pythagorean theorem. So 11 squared plus W squared equals 14 squared. That'll give you the answer for W. Next, find one of the angles. So let's say we want to find angle X. Label your triangle, hypotenuse, opposite, adjacent. And since W, the opposite, was something we just calculated, I probably wouldn't use that number just in case there was a mistake. I'd use the 11 and the 14 that were given to us. So in this case, it's adjacent and hypotenuse. So you're going to set up an equation, cosine of x equals 11 over 14, and solve for the angle x. Now, you don't have to do that again for angle y, because we know this one's 90, and if you figure out what x is, you can subtract those from 180 to figure out what y is. Okay? And then number 2 is likewise. So hopefully this will give you a little bit of challenge, and next time I will go through the answers for this worksheet with you just to make sure you understand this, and we'll practice some more. Make sure after you finish you submit it into Schoology for the assignment, and good luck. Email me if you have any problems or any questions.